All right, I guess we are live now, and if you guys can see me, just give me a thumbs up so that we can take start as I do that every time. All right. So, hello, hi, good evening, welcome, namaste, welcome to yet another edition of Blockchain eWEEKEND, brought to you by Inblocks Events, community partner Decentron. And the topic for today's discussion is the concept of self-sovereign identity. It means in Hindi, Swa Samprabhu Pehchan. And I'm sure, someday, sooner or later, we'll hear Modi ji saying, Mitron, apni pehchan mujhe de dein, aur main Ambani ko de dunga. So, guys, my name is Akash. I'm your host. My job is to warm you guys up before we kickstart the event. I am at my home, and you can see, there are some horses in the background. And horses for courses is what, in blocks events believe in. Right people for the right topic. So yeah, as I said, I'm at home these days. I'm with my parents and my mom, she's after my life to get me married. Not because she really wants to. It's just that she's the only lady in her kitty party group whose son is not married. So imagine the peer pressure on her. She's under a lot of peer pressure so that, she's the only lady, as I said, whose son is not married. She has to face this question every time. When is your son getting married? What's wrong with him? Is he already married or is he gay? So when my mom really got mad, really got worried, and she came to me and said, "What is the reason, son? What's happening to you? Are you gay? What's the scene?" I said, yeah, I could be gay. I thought, to have some fun with my mom. I said, see, you have never sent me to a co-ed school. For 13 years, I was in a boys' school. Then 4 years, I did engineering. I had no contact with girls. The only, female interaction I used to have with were my mom, my sister, and my maid. Imagine the lack of female interaction, that whenever I used to get calls from telecallers women, I would never hang up on their calls. They would say, sir, do you need a credit card? I would say, why not, if you can come and deliver it personally? So coming back to my mom's problem, she said, why don't you be a good son and make your profile on a matrimonial site? So just to convince her, I made a profile on shadi.com, and I played a little smartly over there. In my profile, I mentioned I'm looking for a smoking hot Java developer. And not to my surprise, I didn't get any single match, because all the smoking hot women, they are not doing any sort of Java development. They are into testing or they are into HR. And I can tell this from my experience because I've worked in the field of IT industry for 9 years. I have never seen a smoking hot Java developer. All right, so that's enough, and we have a long lineup, so we'll come to some serious talks, and we will, jump to our topic, which is self-sovereign identity. And there's no consensus on an exact definition of self-sovereign identity yet, but we will try to build one through our panelists. So without wasting any time, I will introduce the panel to you guys, and I'll bring Apurv here. Apurv, you can say hi to the audience. You can unmute yourself.
Hello. Yeah. Hi. Thanks for having me.
Me. Next up, we have Devjani.
Hello there.
You can say hi to the audience. She is author of 5 Amazon bestseller books in blockchain, and her latest is on SSI. So guys, you can check that out. Then we have Nicholas. Nicholas is based out of Singapore. Nicholas, you can say hi to the audience. Nicholas.
Hi. Hi, everyone.
Product management lead at Proximax. And then finally, we have Mayur. Mayur is a very talented person. Mayur is the founder of Newfang. Mayur, you can say hi to the audience as well. And I will now bring Apurv on stage. So please give a warm up welcome to Apurv. Please give some virtual claps, so that we can bring up some energy in the room. All right. So there are these claps, some loves, hearts. For Apurv, you can take the stage over, and it's all yours. I will just hide myself and act as a silent moderator.
Yeah.
All yours, Apurv.
Thank you. Thanks, Akash, for inviting me today. So good evening, everyone. So today on this panel, we are here to discuss what defines us, identity. So digital identity is important. Its assertion, portability, privacy, ownership are the things which we have been talking about from the advent of internet. Even if you look at the advocacy of the creators of public key cryptography, Ralph Merkle, etc., you see they have been continuously advocating about the concept of self-sovereign identity. There have been multiple implementations, protocols being built on top of it, stacks being defined, multiple consortiums being formed to formulate the SSI guidelines, but we don't see anything concrete out there. With blockchain technology coming in, it has personified those thoughts into actual implementations and gave a strong technological foundation to build these SSI or sovereign, self-sovereign identity systems upon. Projects like Uport on Ethereum came into light, and it's proving up to be a very strong platform to build SSI systems on. So I will not be talking much about SSI, but I'll be just relaying the right communication so everything is into tandem. And also, it's been long since we have been battling against cyber attacks and all the things which are going on the internet, protecting customer rights, and now we are at the cusp of developing such solutions which can actually do that. But still we see a lot of identities being compromised. We can see that in the latest Twitter hack which happened, where Bitcoin scam tweets were posted from multiple VVIP accounts, and that happened. So if critically analyzed, that was not that was an attack to Twitter platform, but also an attack to the identity of those people whose accounts were hacked. This reminded us again about how fragile these centralized infrastructure, these centralized systems are, and why exactly we need self-sovereign identity systems. So it's an honor for us today to have such amazing panelists who have accomplished really good stuff in SSI. And I won't waste much time, and I'll give the stage to Debjani Mohanty, who is an accomplished writer, and she has even written a book on self-sovereign identity. So Debjani, the stage is yours.
Thank you, Apu, for such a wonderful introduction. So I'm trying to share my screen. So is it visible on your on the panel?
Yes, it's visible.
Okay, cool. All right. So, all right. All right, so today's topic is adoption of self-sovereign digital identity, and I'm Debjani Mohanty, and so I'm a blockchain author. I've written 5 books on blockchain that you can find on Amazon, and my latest work is on blockchain for self-sovereign digital identity, where you can find different blockchain protocols that if you want to study, if you want to do any projects, so this would be really helpful because you won't find any other book written in this domain so far. So I won't cover blockchain in details. I believe that most of you might have gone through the basics of blockchain, but just a brief that blockchain is an emerging technology, and it's been there in the market for last 1 decade, and it has found its place on the Gartner Hype Cycle for last 4-5 years. So you can see that blockchain adoption has been increasing in 2006, 2017, 18, and 19. You can see that blockchain adoption is on the rise day by day. And in 2019, rather than specifying that where exactly the blockchain adoption is at the moment, the Gartner has come up with a different hype cycle with all the use cases of blockchain. Whatever, I mean, because some of the blockchain use cases are already in production, some of them are still struggling to come to speed. So digital identity is an area of blockchain which is still in its very primitive stage. So there are use cases you can see that which are highlighted in blue here. Decentralized identity, zero knowledge proof, and distributed storage. So in blockchain, so these are some of the use cases of blockchain which fall under the digital identity domain, and this is actually the adoption is increasing 60% year on year, and it's going to go till 2022 in a similar way. So first of all, what is digital identity? So any personal data that identifies you online is your digital identity. So something like your login ID, your password, your national identity number, your social security number, your PAN number, your voter's ID. So all these are part of your digital identity. These are your personal data. So they help you to initiate any kind of business relationship. So in this chart, you can see that if you want to log in, you need your digital identity. If you want to get access to some online stuff, which is yours, then you need your digital identity. If you want to start a business relationship or end it, then you would need digital identity. But there have been major hacks in the world in last 1 decade, and you can see all these data hacks that has happened. I'm talking about the mass data hacks, and most of it fall under personal data. So you can see that in this chart that it has been showing the top 10 biggest data leaks in the world in last 10 years. And you can see some of the biggest names in the market like Adobe, eBay, and Anthem. And the kind of data that got leaked has affected actually millions, not one or two, but millions of people. This mass data hack. And the type of data that got leaked are something like the name, your address, bank details, credit card details. So the person who gets access to this kind of data can really hurt you, like maybe financially or otherwise. So what are the biggest cause of this kind of data breaches? The biggest issue is centralized server, because in a centralized server you have got information of millions of people, like what I'm showing over here, 200 million, 191 million. How somebody gets access to this kind of data is only because that the data is stored in a centralized server. The second one being weak passwords, but the first and major one is centralized server. And also in the right hand side, you can see there are so many regulations devised by many countries in the world and many organizations who are aware of this kind of issues. So if you are working in European Union, then you have to abide by GDPR. In US, you have CCPA. In healthcare domain, anywhere in the world, it's HIPPA. Similarly, for payment cards, it is PCI DSS. So similarly, even in India, PDPP, there is an act called PDPP, which is in draft form, which is related to the regulation of personal data, which is in draft form, but can be, it can be granted anytime. Similarly, in Singapore also, PDPA is already working. So now coming to the how we manage the digital identity part. So people like me who have been into the industry for more than 2 decades, so we know that the digital identity, the way we store it, the way we manage it, has evolved in last 2-3 decades. So like in 1988 to 1998, it has been centralized identity. The only way of storing identity was centralized. But from afterwards, there was something called federated identity. I'm going to discuss more on this. Then there is user-centric identity, and finally I'll be discussing self-sovereign identity. So the centralized identity is one, like we all might have seen how the way we log in. So most of the applications would want you to log in using your user ID and password, and that information goes to a centralized server. So it might be Active Directory or LDAP or a regular database. So the problem with this kind of storage is mass hacking is possible, which I already discussed, and single point of failure. The second one is federated identity. It's just like, instead of the same server getting hold of your identity data, you are having a separate server who is managing your identity. This is the green one is the identity provider. It's just like, you want to log into Google. If you log in once to the Google email, you do not need to log in to Google Drive anymore. So the same authentication works, because there is a identity provider who is granting you a token, and using the same token you are getting access to different third parties under the same Google umbrella. So in this architecture also, mass hacking is possible, because here your centralized server is your identity provider. And also single point of failure is possible. Now the third stage of the way identity has evolved is user-centric identity. Here, there was a problem with this architecture. I'm not going to go to details, but this is the first attempt to go decentralized, because the problem with the previous two forms of identity management was centralized. So that is why people started thinking about how to decentralize your the stories of the identity. So they came up with this model. This model didn't work. So now what we are talking about is self-sovereign digital identity. So in this model, we have a issuer, which is an organization, then a verifier, which is another organization, and the user has got a wallet. So issuer is something like, let's say the passport office is assigning you, the user, a passport. Now this data goes to the user's wallet as a digital data. So this wallet is also a private data. And the verifier is, let's say, the visa office. Now the user can share all of his data or part of his data to the verifier or the visa office. So visa office in today's state, the visa office does an independent query that the visa office connects to the issuer or the passport office to check that whether the data provided by the user is fake or not, like the passport information is fake or not. But in this new model, we have a blockchain. Please note that the blockchain has got information of the issuer, the user, and the verifier. Only their identity or decentralized identity is known to the blockchain, but the actual data is stored in the user's private wallet. So when the issuer is assigning any credential to the user, the issuer is also sending a reference to the blockchain, not the real data, but a reference to the blockchain. Now the verifier is going to the blockchain and checking that whether the data shared by this user is right or not. So this is the model of self-sovereign digital identity. So here the user has full control on his data. So user might be having data from different sources, like from his university, the educational data, from his healthcare, from his some government data. So different kind of data could be stored in his wallet, and as per the need, the user can showcase a mixture of data, whatever is needed, to the verifier. Right, so this is the model of the self-sovereign digital identity. And also, in a later date, let's say that the issuer has assigned a certificate which is valid for 1 year, for whatever reason. Now, at the end of 1 year, the issuer would just revoke it on the blockchain, revoke the reference on the blockchain, not the real data, as I said. So once the issuer revokes it, the verifier can see that the data was issued, but now it is no longer valid. So in this model, all the purposes, the issuer's purpose would meet, the user's purpose would meet, and the verifier's purpose would meet. So this is a fantastic model if you want to store your biometrics data, because biometrics, that India has Aadhaar, and Aadhaar is the biggest biometrics database in the whole world. And biometrics has got a problem that you cannot keep biometrics in a centralized server, because if someone gets access to your data, then you cannot revert, like, because if you log in with your user ID and password and somebody hacks it, you can use a separate user ID and password. But in case of biometrics, if you're logging in using your biometrics, the biometrics cannot change. So it is really needed to make it decentralized, so that your biometrics goes to your own wallet, and next time whenever you are logging in from your mobile device, registered mobile device, you are sending the same biometrics online, and it is getting matched against your wallet. So this is a new model of authentication. Many organizations in the world are working on this model. So this is yet to be seen. Maybe in a year or two, you'll find many different use cases coming to the market, like e-voting is one. Somebody can log in from his registered mobile device and cast a vote, which was simply not possible before. So remote onboarding, the student is registered to a university from a remote place. A customer is onboarded online to a bank. The customer doesn't need to visit a bank to create an account. Similarly, the employee is getting onboarded to his new office, to a new employer online, because his identity can be shared through a video call, and the person can also showcase, that whatever information is with him is actually his, shared his facial details, whatever, and it is matching with whatever is there in the identity wallet. So this is a new model, and there are many new business models possible because of this SSI, and it could be affecting. You can work in any, doesn't matter whatever verticals you are working in. This new model you can adopt. The SSI is still in a phase to mature, but in a year or two you'll find many different new use cases. And you can see in this right hand side, you can see this map that governments all over the world are working on digital identity in some way or the other. So in India also people are trying, in Australia, in UK, name any country in the world, people are working in this area. And the biggest project on digital identity is ID4D by World Bank, and their target is to create an identity, a decentralized identity for each and every person on earth by 2030. So as of now, for your information, 1 to 1.5 billion people in the whole world do not have any kind of identity with them. So most of them are in countries like in continents of Africa and South America. But in days to come, with this new model, they'll get access to many different resources, maybe education or financial. It's not that they are poor, but the problem is the infrastructure maybe. But with this new model, new possibilities would open. And also, like I said, that many organizations and many countries in the world have come up with their data privacy law. And just like GDPR, after the GDPR became was approved, then the company started working in that regard. So similarly, in a year's time, maybe you'll find a lot of companies in India whoever are working with personal data, they have to revive their laws, revive their work to match it as per the standards of PDPA or PDPB, whatever is applicable. So thank you so much. I think that if you need to learn more, you can read this book. And just to let you know that there are blockchain protocols especially made for digital identity. So they are like UPort and Civic, and then Hyperledger has Hyperledger Indy and Hyperledger Aries, and Microsoft is also coming up with a protocol called Ion. So a lot of work, and you can see that happening in next 1 year's time. Thank you so much.
Thank you, Jeevdari. It was great to listen. So from this, we can understand the entire evolution of identity, where exactly it came from, the centralized portion of it, then going to the federated identity, and now self-sovereign identity. So from where I see it, there are 6 things which compose a self-sovereign identity, which I've been reading a lot about. So one is existence, control, access, transparency, persistence, and portability. So coming on to this, let's welcome Nicholas to the stage, and let's see what Nicholas has to say about SSI. Nicholas, the stage is yours.
Perfect, thank you. Can you all see my screen?
Yes, Nicholas, we can.
Excellent, okay. Hi, everyone. So as we've heard so far today, self-sovereign identity can transform many aspects of our daily lives. For my talk, I'll be sharing insights on how self-sovereign identity can create a new paradigm for KYC compliance. Know Your Counterparty, KYC, is a workflow used to verify counterparties according to regulatory rules. We should all now be familiar that this process involves a lot of complex, costly, and time-consuming manual verification, leading to operational inefficiencies and poor user experience. As the financial industry becomes more digitalized, the next generation of fintech applications need to filter and analyze growing amounts of data. KYC verification has become a roadblock to the industry due to heavy reliance on human intervention that involves back and forth communication and repetition. It also suffers from data breaches and identity theft. Blockchain technology presents a powerful solution to this problem. It improves KYC workflows by making it possible to transmit instantly verifiable claims. Also, it enables zero-knowledge proof verification, meaning minimal or no disclosure of personally identifiable information. So blockchain makes this possible by creating trust between opposing parties. As digital identities and their associated credentials and data can be verified on the ledger. It also makes it possible to own and control your digital identity and KYC data, creating a new paradigm for KYC compliance with simple workflows, lower cost, and enhanced data security and privacy. A self-sovereign identity is represented by a unique decentralized identifier. It is basically a string of characters made up of a DID method and a blockchain account. You can easily generate a self-sovereign ID and prove control over it using cryptographic proofs. In contrast, the vast majority of unique identifiers we currently use are centralized and not under our control. These include communication addresses such as emails and telephone numbers, and IDs such as passport and tax numbers. So the external authority can decide who or what they identify. They may be useful in only a small specific context. They may cease to be valid with the failure of the authority. And most worryingly, they may unnecessarily reveal personal information and make us subject to identity theft. So self-sovereign identity solves this by enabling a human-centric control over digital identity that is not dependent on a central authority. We all need to make many kinds of claims as part of our daily activities. For KYC compliance, this may include having to prove your nationality, your residential address, and source of wealth and funds. Self-sovereign identity enables your claims to become instantly verifiable. So how does this work? First, you generate a self-sovereign identity using a personal digital wallet, which acts as a window to the blockchain. A credential issuer, such as a government or a bank, performs due diligence checks and then tags a credential to your digital identity. This action constitutes the signing of a transaction on the blockchain using cryptographic keys. The credentials can then be attached to extended data, such as a passport copy or source of wealth documents from the bank. You can then use these credentials as instantly verifiable claims, such as having a valid passport or being KYC approved by the bank. These can all be verified by third parties in real time. Each of these steps that I've showed you constitutes transactions on the blockchain, which we can be executed simply by scanning a QR code. During verification, you can control the exposure of your personal information. Instead of full disclosure, such as access to a copy of your passport, zero-knowledge proof enables disclosure of only what a verifier needs, such as just the passport's ID number, country of issuance, and expiry date. Verification can also be a predicated proof. So that means the answer to a yes or no question. For example, are you a politically exposed person? There is trust because the signing of the blockchain transaction during verification is a cryptographic proof, meaning it proves that you control the associated private key. An issuer can revoke your credentials by recording its status in a distributed and decentralized user registry. So scenarios where this action is needed include when your bank account closes and during offboarding. It would also be possible to blacklist digital identities using the same method, which is essential if, for example, a positive hit is identified for money laundering offenses or international sanctions. All this translates into a much more robust infrastructure for our booming digital economy, lower business cost, stronger trust between counterparties, and more seamless user experience. For example, an association of companies with the same standard of KYC compliance could use self-sovereign identity to easily share customers. A platform for B2B transactions could use self-sovereign identity to create a marketplace with verifiable and reputable trade partners. Supply chain counterparts could use self-sovereign identity to ensure ethical sourcing and sanctions compliance. Remitters could use verifiable claims to verify the sender and the receiver of funds instantaneously. And the authorities could blacklist digital identities and make this verifiable across interoperable networks. So you can see, you can find out more about self-sovereign identity and perform live demos on our website. Thank you for listening.
You're on mute, Tapu.
I think there's some issue at Apur's end. So anyways, he had to bring on Mayur now. So let me just bring on Mayur on stage. Mayur, all yours. Mayur, you are also on mute right now.
Oh, fantastic. I had to do that. I hope I'm audible. All right, let me quickly jump into it and share my screen. I hope everyone can see what I have here. I'm guessing yes. Yeah, hi. So my name is Mayur. I'm the founder of a company called Newfang, where we're building a decentralized cloud storage platform. And we're currently working on a product called Schism, where we want to leverage the decentralized storage platform that we built in order to make it possible for people to send and receive files with end-to-end encryption, right? So in both our projects, we've done our own implementation of SSIs and especially DIDs. It's slightly different from what you normally understand SSI to be, but I mean, a lot has been covered by both Devjani and Nicholas in terms of what SSI is and where it could be applied. I think it's kind of relevant to also understand the why of SSI. I think the simplest way to think about why SSI is probably necessary and why it's relevant to just about every human being that on this planet is asking a simple question of if you had to choose between losing your mobile phone or your wallet or losing your primary email ID, which one would you pick? Right? I think if we all kind of spend some time, I'm pretty sure most of us would arrive at the obvious answer that we'd like to save our email ID, even if we end up losing our wallets and mobile phones. And the reason for that is because my primary email ID has become my identity for so many different things, and it's become also my source of two-factor authentication and things like that. And it's just become so integral. And when you extend this, and we obviously understand this concept much better than say some of the people who are not exposed to the kind of knowledge and information that we have access to. And but imagine just, I think Devjani kind of touched upon it when talking about the concept of e-voting. And if that is something that gets introduced in the next few years, even in a country like India, what are we to do when people's identities are either getting lost or voter lists are being deleted and things like that? So the critical point to find here is that the reason why like centralized identities services, like say for example your email and things like that, or even federated identity services, just kind of will eventually fail, is that if the user does not really have control, then it becomes a huge problem. So there are some fundamental principles that kind of guide the design of any self-sovereign identification system. And this was written by Christopher Allen. He's one of the pioneers of SSI. And it talks about these 10 things, right? They're pretty self-explanatory. It talks about an identity which basically defines a person's existence, right? It should be independent of anyone else or their surroundings or their geography or their political affiliations, any of those sorts of things. It says that users should obviously be able to control their identity. It further goes on to talk about how obviously users need to have access to their own data, which is, if you look at things like GDPR, which kind of successfully does some of these things. The same should apply even to all the data that kind of comes together to form your identity. Then it talks also about transparency, which basically means that any system that is used to kind of generate and hold and perform operations on a person's identity should be completely transparent, open source. The inner workings and the business logic behind it should be something that can be easily audited and publicly verified. It also talks about persistence, saying that identities should obviously persist for a very long period of time. They should be portable in the sense that they should play well with each other, which basically goes to talk about, say, how your social security number is useless in another geography outside of the US. Interoperability, so basically straightforward again, it should be able to kind of play well with various systems, like how you could take the example of Aadhaar today, kind of allows you to get access to not only like a wallet, but also do KYC for your bank and so many other sort of things, right? And consent. This is, I think, the crucial part, which basically means that any sort of activity that has to happen with my identity, it should require my consent. And minimization, which is basically what all information is kind of shared, should be absolutely minimal, in the sense that if for example, I mean, the simplest example for something like this is if you have to go to, say, for example, to a liquor store to buy alcohol, and you need to prove that you're over 21 or 18 or whatever the rules declare. Right now, you kind of hand over your driver's license to the person, and they kind of have complete access to your entire license data, whereas all they needed access to was just your date of birth. So there should be a mechanism to kind of be able to kind of share this appropriately. And then just general protection, right? So user privacy and user rights kind of need to be protected. So a lot of these are the guiding principles that have gone on to describing what is currently a very active work at a working group with the W3C with regards to what Nicholas touched upon, which is DIDs or decentralized IDs, right? The concept of being able to assign an ID that is not controlled by any central authority or state. And this is the link to the active work going on there. There's a wonderful specification that is already out there. It's still evolving, but it is very likely that this could become like a W3C standard in probably the months or maybe a year or so to come, where this could actually have very real-world impact. Already people are building on top of this spec. I know that we at Newfang have actually gone ahead and done so ourselves. So I'd like to kind of spend some time like having established like the why of the SSI and what you can actually start doing, and how do you go about like implementing SSI or any sort of digital identity on a decentralized network, right? And the DID spec is the great place to start from. So what is a DID? A DID is like you all know is basically an identifier, right? And this is how a very basic, simple DID looks like. And it is basically a URI. Just like how you have HTTP:// and then you have your entire URL, which kind of describes the location of something. It's quite similar in that form. So it adheres to that standard, the URI standard, where you have three components basically, where you have one which is the standard URL scheme identifier. In case of HTTP, it's HTTP. In case of DIDs, it's just DID, right? The next part, they're all separated by colons. And the next part is something called a method identifier. This is the way in which this DID is generated. So typically, this would either be a service that you use, like say Uport or Sovereign, or if you are building your own DID, then this is probably going to be your own custom name that you've given. In our case, ours is called Newfang. And then lastly is, of course, the method-specific identifier that is generated. And this could be any sort of identifier that you generate that could be very specific to your system. But at the same time, going back to the principles of SSI design, it's very important for this identifier to kind of be as unique as possible. And in a lot of cases, this identifier, I mean, it could be just a mobile number, it could be your email, it could be the hash of the address that where things are stored on IPFS. It could be any of those sorts of things, right? So all of this put together constitutes a DID, which eventually is a globally unique and globally resolvable identifier. That's what the DID spec sort of wants you to get at. So everything that this DID kind of describes has to be globally unique, so that there is no other copy of this that ever exists, and it also needs to be globally resolvable, which basically means that if I were to go to my browser and type in a URL, I'm able to go to a particular website, and I can do so from anywhere in the world on any browser, except if you're in China, of course. But So in a similar vein, I should be able to take a DID and go to a DID resolver, which is like analogous to your browser search bar, and I paste it there, and I should be able to kind of resolve to something. So what is this thing that a DID resolves to? A URL resolves to a website. A DID resolves to what is called a DID document. And a DID document is basically what the contents of this document are basically a whole bunch of information about the particular thing that the DID is describing. Right. So this DID could, for example, be a decentralized ID for me, Mayur, the person, and the DID document then will contain a bunch of different things, which actually will describe ways in which you can sort of interact with me. It describes some public information that are made accessible to people. And just to kind of give you a quick example, this is what a sample DID document could look like. This particular example is a JSON linked data, JSON LD format. And what it is basically it describes a bunch of things, but most importantly, it describes something called public keys, or basically, who is the this particular identity describing, who is the owner. So it would usually have, say, my public keys. If this was an identity for me, it could describe a controller. For example, this could be an employee's identity where the public key could be of the employee and the controller could be the employer. Then it describes authentication, where basically the different ways in which this particular ID or person that this ID describes is going to authenticate that they in fact control this ID. And basically, next to a bunch of service endpoints. Things like how what it describes is the various ways in which you can interact with whatever it is that this ID is describing. So, for example, this could have links to a bunch of different services. Like, for example, my Twitter handle could be here. So, how do you contact me on Twitter could be a service that is described. How do you get access to my date of birth if you are doing KYC for my particular identity and things like that. So a bunch of different services can be described. So this is a standard structure, and the idea is that this can be applied to just about anyone and anything. This could apply to an IoT device. This could apply to a real human being in Nagaland, or it could even apply to like a thing, for example, a laptop that the company has given, right? So anything that typically has identities is what this would describe. So how does this all function, right? So at the very center right here, you have what is called the DID, obviously. And what the DID does is that it identifies a DID subject. And like I just mentioned, the DID subject could be a person or a thing. And there is a DID method, which is usually something that you would describe if you are building a DID system, and you give it a unique name, and that is what actually generates the DID. So how Google goes about generating email IDs is in a similar vein. This DID method goes about creating this DID. And this DID is recorded on a verifiable data registry, as it's called, but in the simplest terms, this verifiable data registry is say the blockchain of your choice that you're using. For example, it could be just the Ethereum blockchain. And what the DID does is it points to the DID document, right? So it's just what we saw just some time back. And then you have a DID controller who can basically modify contents within the document. So if it's an employer who's controlling your particular DID as an employee of a particular company, you end up having a scenario where your employer could update details. So this is sort of like the broad structure of how DID works. And the idea is to have multiple DIDs for all your different sort of interactions, right? So if I should have a DID that describes me as, say, an Indian citizen, where there is, say, the government of India is helping me create this DID, which describes me as a citizen. Then you have like Johnny was talking about the passport office, and I have a separate DID that governs, say, my passport. I can have a different DID with my employer, and I can have a whole bunch of DIDs for various kinds of interactions. And the idea is to not just limit it to one central thing that kind of everyone sort of interacts with. So yeah, I mean, this is just scratching the surface. A great place to kind of go and check things out is the DID spec. And what we are doing at Newfang and Skizzle is we are giving DIDs to files. So because we are a file storage and file sharing platform, we end up giving DIDs to files, which means that a file that you upload to our system has a globally unique ID that is globally resolvable, and it also is something that says that you are the owner of this particular file, and there are different ways in which you can interact with this file through various service endpoints. So that's how we've gone about actually doing our implementation. And where this starts to become very powerful is for content creators. So if you're a photographer or a digital creating digital assets at your home or creating NFTs and all of the sorts of things, we have a way to be able to kind of prove immutably that this particular digital asset is owned and controlled by you. And what helps us achieve doing that is actually the entire concept of DIDs. So yeah, that's a great place to start. And if you have any questions regarding implementation or real world applications and things like that, feel free to reach out to me. Thanks.
Thanks, Mayur. That was a really in-depth analysis of what DID is, and as you said, it's just scratching the surface. So we have a lot of questions around here. And we have so much less of time right now. So I guess let's start taking up the questions. So this question by Steve is interested to hear what the panelists think about the Twitter hack in the context of SSI. Any insights shared would be appreciated, as it's an extremely interesting topic when it comes to identity and privacy. So Mayur, would you like to take this up?
Sure. So I mean, in the context of SSI, the Twitter hack, basically what happened was social engineering allowed a kid basically sitting in his basement and a bunch of other guys to take control of like a God mode account on Twitter, right? And so basically he got some admin credentials and then was able to use various accounts and get into them. And like they've done earlier talked about how centralized systems kind of fail is when stuff like this starts to happen, right? And just to kind of try and tie that back to SSI, if the identity mechanism or the access management was more decentralized, where it was actually more user-centric than it is centralized in the case of Twitter, this would really not happen, because my Twitter identity could just have been like a DID that I own and control, and no one on Twitter side or any hacker can actually, as long as I keep my keys private, no one could gain access to my my particular account. And this applies to any system.
All right.
Could you please unhide your screen
yes,
so that we can bring people on the center?
Oh, sorry.
Unshare the middle
You need to stop sharing your screen. Yeah.
I did, I think. Oh, yeah. Sorry. Yeah.
Thanks, Mayur. So there's another question from Vikram Bhushan. The question is, will there be possible ways the issuers such as government somehow not be on the SSI network, and still we have some sort of verifiable proof that a pseudo information is verified over the government network, for example? So Nicholas, would you like to take this up? As you talked about KYC and everything. Nicholas?
Yeah, before Nicholas takes up this question, let's just ask Steve if he's satisfied with the answer, and just I can remove him
Yeah.
from. So,
Yes,
Steve?
I most definitely am. Thank you so much. And I
All right,
actually
Steve.
shared a link in the chat that will I think will make all of you guys really happy too. It's quite nice.
Thank you so much, Steve.
Hi. Could we repeat the question? Is that the one?
So the question says, will there be possible ways the issuer, such as government, somehow not be on the SSI network, and still we have some sort of verifiable proof that a pseudo information is verified over the government network, for example?
Yes. Well, for that there need to be interoperability. So the networks would need to be, for instance, the most standard one that's being used now is W3C, the World Wide Web Consortium. And so if all the networks have interoperability and with the use of zero knowledge proof, I think that, yes, it can be done.
Thanks, Nicholas, for that. So we are running out of time. So I guess Akash will now allow me just to take one more question. So for Devjani, it's your question. The personal data recovery of users, what could be the ways we could think of when going on SSI? So how exactly there could be personal data recovery done when the SSI is in place? You are on mute, Devjani. Can you please unmute?
Oh, sorry. Yeah. Okay. So I hope you can hear me now. All right. So in SSI network, we have two different artifacts. One is a deed, a decentralized identity. The other one is the private key. So how it happens is like if you want to rotate your key, maybe your key is maybe your mobile device which is connecting to the SSI network is lost, or maybe you just simply just want to just like resetting the password you want to reset your whatever key that you are using. So how that happens is we keep the deed part intact, right? So data is actually associated, your personal data is associated with your decentralized identity, right? So your deed part would be intact, but a new set of private and public keys would be generated, and that would be associated with the deed, and the previous would be discarded. So this is the model. So using which you can just like resetting your password, you can use a new private key. You can keep on doing this from time to time just for the increased security, or maybe if your mobile is stolen or broken whatsoever, you can use this method.
All right. Thank you. Vikram Bhushan, are you satisfied with the answer? Okay, Akash, can you please bring up Vikram over here?
Vikram was not there. I tried to find him, but now he's back. Yeah. Let me just call him on stage. Just a second.
Yeah.
Amazing, when I'm trying to search him, I cannot find him. I think there's a mode where you cannot invite people on stage.
No worries, no worries. He has said on the chat that he is satisfied with the answer. Perfect.
All right.
So now there's one question from my side. I think that could be the last question for today. I have been reading that identities cost a lot. I mean, taking the assurance of an identity or assertion of identity, and then processing the right kind of assertion by institutions like FIs or other identity providers. There's a lot of cost induced. And I just went through an article a few days ago that the yearly cost of assurance of identity in UK annually is 3.3 billion pounds. So, and just if we think that on a global level, that is a huge cost. So, I mean, what are your views? I mean, how exactly SSI can reduce the cost of assertion and assurance of identity? Anyone?
I can take a quick stab. So I think it basically asserting identity is in a centralized setup is a huge cost thing, primarily because of the red tape that comes with it, right? And the inefficiencies, inherent inefficiencies that exist in trying to prove things. Like if I have to assert certain things about my identity, I usually have to start dabbling with legal matters. I have to start dealing with administrative red tape, and all of these sorts of things start to come into picture, which eventually leads to either me spending a lot of time or actual money, or we're not even talking about things like identity loss and what you do to kind of get reconcile that situation. So in my opinion, when you can use real world cryptography, and when you can use technology such as blockchains to kind of say that to kind of assert this almost automatically and allow it to be mathematically proven by cheap servers, I think you're able to kind of drive costs down massively, and because there are no inefficiencies. The only stuff that would come is being able to verify certain things, which would probably be external to the system and more real world. But even then, you're driving costs down by orders of magnitude, in my opinion.
Great. Thanks, Mayur. So with this, I would like to wrap up my moderation and bring up Akash to close the session. Akash?
All right, Apurv, thank you so much for moderating the entire session. Great help from you today. And I would like to thank all our speakers, for giving some valuable insights on the concept of SSI. I hope the audience learned something as well today. And, they go back there. I think they're already in their homes, they take back some good points and learning from this session. And we will see you guys next week because Blockchain eWEEKEND is happening every Saturday. Please do check out Crypto eWEEKENDs as well. It happens every Friday. We started this yesterday, so it will happen every alternate Friday. So you can calculate when's the next Crypto eWEEKEND. Of course, you can follow us on Twitter, LinkedIn, and Instagram to watch out more updates on events that Inbox Events is, conducting for you guys and doing a great job for the Indian blockchain community. All right, see you guys. Have an awesome weekend. See you next week. Thank you so much.
Thank you.
Thank you, everyone. Thank you.
Thank you, guys.
You could just wait and meet me at the backstage. We'll take a picture.
Yeah, photo op, right?
Yeah.
Yeah.
Sure.